Prototyping, it's very important in the development process. It gives you, the engineer, the possibility to verify the design and avoid costs and downtime. Additive manufacturing, it gives you the opportunity to produce parts very quick, very efficient. So looking to the development in direction of electrification, the development times are getting shorter. So that means the time you have to develop parts, verify parts or vehicles, it's getting shorter, and therefore it's very important to have this technology in the development process. Makes you much more competitive. Ford Cologne was founded in 1930. The development center PD Merkenich here develops passenger vehicles from ground up. We produce very famous models like the Ford Fiesta, the Ford Focus, and now our latest and newest model, which is the new Explorer.
We have several additive manufacturing machines. We have injection molding and also subtractive manufacturing, for example, milling. At Rapid Technology Center, we are using from Formlabs, desktop printers, large SLA printers, and also fuse selective laser sintering printers. SLA machines are used mainly in our workshop for design prototypes, so that you have a good quality, surface quality, and needs to be very fast. The Form 4 is very fast. I think is the best machine that I saw until now in terms of speed, and is really a very good upgrade comparative to the previous models.
Working with Form 4 is really a game changer. The speed of the printer will change our workflow. We can deliver more parts, the throughput is higher. We are much more flexible. We have, let's say, short-time requests. Now we can do this using the Form 4. You can start parts in the morning, you can have it in the afternoon.
Some years ago, it was days. Now we are just printing parts in some minutes. The engineers are not afraid to make new designs, new iterations, because they know now that they will get the parts very fast. For the new Explorer we are producing now, we printed several prototype parts from interior, from exterior, that help us to validate the design. The Form 3L enables us to print big parts, for example, exterior body parts for the vehicle. We print this mirror cap to validate the design. 3D printing is suitable for this application because it's fast and we can have very good quality comparative to mass production parts. We are using SLS Form testing mechanical parts, mainly because the engineers are requiring prototypes with materials that can be tested on field. We are always trying to test, validate materials that are more similar for mass production. Fuse 1 Plus use PA12 that is very similar to our injection molding mass production parts. The fuse is much faster than the competitors. It's very easy for the operators to operate the machine, and very easy for us to deliver the parts faster. The blasts speed up our process tremendously because the operator don't need to clean the parts manually now. Just put it there inside of the box and start the machine. The discharging cover was important to use in SLS based on the fact that we need a functional part to test the mechanisms. It's really complex design that we are not able to produce this in another way. We cannot mill this part. We cannot having injection molding to produce just some samples. So the best way is to print in material that we can test it physically. Having these synergies in-house, all these different technologies, we are able to decide which part will be produced based on material, cheaper, faster. So we are combining all these technologies. We see a lot of potential using 3D printing inserts for injection molding based on the fact that we can iterate the design very fast. So we print cavities in cores and then we can change in the tool and then we can inject the parts. We produce the rubber part in the door handle using injection molding in-house with the help for additive manufacturing. This was a complex process because we are using several inserts, and also there are several different designs that could be with several iterations. A normal externally injection molding will take maybe 2-3 months of working, and internally using additive manufacturing we can speed up the process to maybe 2 weeks, 3 weeks maximum. So our competitors are speeding up the developing process. We need to speed it up as well. The solution is to test new materials, new processes, new machines that come to the market. Currently, if we are not having access to additive manufacturing, we were not really able to compete with the competitors. We were not able to be so fast. 3D printing allows us to, in a shorter time, have the best product that we can offer for the clients.
you.